Hello students, welcome back to my channel. So this is our first problem related to the DC circuits. What we have to find out and what is the question statement that is given here basically. So the circuit which is given here, we have to find out the value of R if the value of this VG is given. So the value of this VG is given, the value of current is given, and we have to find the value of R and the power absorbed by the resistor. So as basically approaching towards the solution of this problem, we know that according to the KVL, we have a solution that the sum of all voltage rises in a circuit are equal to the sum of all voltage drops. So here we have just one passive element and one active element. Therefore, the value of Vg, which is the voltage rise, is equal to the value of VR. So what we can see here that all the voltage generated here or provided is basically consumed by this resistor. So we know that this is VR and the value of VR is basically I into R. So to formulate any question or to find out any quantity with respect to any circuit element, we should have some understanding of any elements. So let's say we have any element which is denoted by Z here. So if we have to find out quantity, any quantity related to this one, so actually we have three quantities related to any electric element, which are the current, is impedance or resistance, you can call it for the DC circuits, and the voltage drop across this element. So out of these three elements, if any of the two quantities are given, we can easily find out the value of the third quantity. So here we have Vg, which is already dropped here. We know the value of current, which is Ig here, and we have to find out the value of R. So by this formula, we can easily find out the value of R, which is Vg by Ig, and putting the values here, 1K divided by 5 milli, or 1 by 5 into 10 raised to the power 3 into 10 raised to the power 3, which is 1 by 5 10 raised to the power 6, or 1 by 5 mega ohm. So this is the value. This is basically a very easy question. This is a very easy question, very basic question, but what is the thing which I want you guys to understand is the basics of a KVL. This is a very easy question. Suppose this is something which you have in total, so whatever you have will be consumed equally, whatever is available here. So this is, let's say, R1, or we have any other resistor R2 here. So whatever here is will be basically consumed here and here as well, and the sum of all voltages will be equal to VR1 plus VR2, and this is called KVL. This is the second part of this question which we have solved here. So basically, in approaching the questions like this one, first we have to find out the solution of a very easy questions, and then we will try to approach toward these solutions. Okay, after finding out the voltages here, what we have to find out, we have to find out the value of power which is consumed, and we know the formula of the power which is consumed is I square R. This is the formula for finding the power consumed by any passive element. So this is I square R, which is basically Ig square into R. We know the value of Ig square. We know the value of Ig, which is 5 into 10 raised to the power minus 3 square multiplied by 1 by 5 into 10 raised to the power 6. So finding out the values here, this is 25 into 10 raised to the power minus 6 multiplied by 1 by 5 into 10 to the power 6. So these two will cancel out because of the exponent rule, and 25 multiplied by 1 by 5, and ultimately we will get 5 watts. So this is the value of power which is consumed by this resistor here when a supply voltage of 1 kilowatt is provided. So basically in this question, let me remove it. This was our question. So basically in this question we have only one resistor. Whatever is produced here is consumed by this resistor. Suppose after it we will have another question in which we have two resistors like this one, and we want to find out, this is, let's say, 10 volts, this is R1, this is R2. Suppose we want to find out the voltage drops across each element here. So how can we find out the voltages here? It is very easy. As I told you, this is a very simple circuit. So to find out the value of voltage across R1, we should have I1 as the value of R1 is given. So when we have I1 R1, so we can easily find out by using the Ohm's law. Similarly, to find out the value of V2, we should have I2 and R2. So these are the three very fundamental quantities. If you want to find out the value of any of the three quantities, you can easily find it out by having any two of these three quantities. After finding them out, you can use the formula, which is I square R or V square divided by R. These are the simple rules of the DC circuit analysis. So this was our first lecture, or we have solved this question. After it, after we will approach toward other questions of similar kind, in which I will try to clear your concept regarding the DC circuits. So hope to see you soon. Okay, goodbye. Welcome back, students. So last time we solved a very rudimentary or fundamental circuit in which we had only one resistor. So in today's problem, we will try to solve a circuit which has more than one resistor. So this is one of the circuits in which we have three resistors, which are named as 3 ohm, 7 ohm and 2 ohm resistor with a supply of 24 volt. And what we have to find out is the statement is for the circuit shown, calculate A, I5, which is the total current, B, V1, which is the voltage across 2 ohm resistor, V2, which is the voltage across 3 ohm resistor, and V5, which is the voltage across this 7 ohm resistor, and the power delivered by the 24 volt supply. This is the power. This is an active element which has to provide the overall power. So before approaching the question, we have to look at the nature of the circuit, and after looking at the nature of the circuit, we can easily find out the value of the current which is provided by this source. So initially we have to calculate a circuit which is like this one, or we have to convert this circuit into a circuit which consists of only one resistor, which is the equivalent resistance of this circuit, and it is connected with our 24 volt supply, which basically is providing us the current I5. So here, this is the circuit which we have to convert this circuit to. So actually here all the three resistors are in series. Why are these in series? Because these are connected in such a manner that the value of current in these three is basically equivalent. So the value of I2 is equal to the value of I5 is equal to the value of I1, and that is basically the total current here which is provided by this source. So you can see here that this is a series circuit because all the current is flowing to all the resistors. So in any series circuit, we know that the value of the equivalent resistor is R1 plus R2 plus R3 up to the nth number of resistors we are connected here. So here to find out the value of equivalent resistance, here we have three resistors which are R1, R2 and R3, and R1 plus R2 plus R3, and their values are 2 ohm plus 3 ohm plus 7 ohm. So the equivalent resistance will be 12 ohm here. This is the equivalent resistance here which we have find out. So the value of this equivalent resistance here is 12 ohm. So to find out the value of I5, again the scenario is like the previous question, that this is the sole voltage source here and we have only one passive element. All the voltage generated here will be consumed across this equivalent resistor, which is V equivalent, and this is 24 volt. So to find out the value of current here, we know that actually the associated quantities with any passive element are three, which are I, V and R. These are the three quantities. If we have any two of these quantities, we can easily find out the third quantity by using a very famous law which is called Ohm's law. So here again here we can see here that the value of V equivalent is equal to I5 into R equivalent. This is by this formula, which is Ohm's law across this equivalent resistors. So the value of I5 is V equivalent divided by the R equivalent. So the value of V equivalent is 24 volts, which is the total voltage which is consumed here, and the value of R equivalent is 2, which ultimately give us the value of 2, and the unit of the current is ampere. So this is the total amperage which is consumed here. So now to find out the other quantities here, let me change the color and make it green. Okay, so to find out the other values which are V1, so V1 is basically equal to I5 into 2 ohm. So the value of I5 is 2 multiplied by 2, and this is 4 volts according to the Ohm's law. Similarly, the value of V2 is I5, which is the same current across all the elements, is multiplied by 3. So 2, which is the value of I5 multiplied by 3, is equal to 6 volt, and the value of V5 is equal to again I5, which is similar across all the three elements, multiplied by the value of resistance, which is 7. So 2 multiplied by 7 is equal to 14 volts. So these are the three values which are calculated here. Let me change the color. So this is V1, this is V2, this is V3, and as we already know, these are the quantities which we were asked to calculate, and the values are available here. So these, from these three values we can easily basically prove the KVL theorem, which says the sum of all the voltage rises is equal to the sum of voltage drops. So here the voltage rise is this voltage source, because the direction of current which we have seen is from entering from the negative end and coming out from the positive end, and from the passive elements it is coming at the positive end and coming out from the passive element at the negative end, which will always remain same accordingly. So the adding all these three voltages, which are V1 plus V2 plus V5, and adding them together, 4 plus 6 plus 14, and ultimately we will get 24 volts, which is also the value of the supply voltage or the source voltage. So this says basically that the voltage supplied is equal to the sum of all the voltage drops across all the elements. So this is the supplied voltage. Similarly, to find out the power provided by our source, which is P of S, is calculated by the formula, which is the total current multiplied by the source voltage. Okay, so the value of IT is basically I5, which is the total current in this circuit, and the value of supply voltage is 24. We have found out the value of I5, which is 2 multiplied by 24, and the supplied voltage is 48 volts. So this is another basically very basic question in which we have calculated the voltage drop across all the series connected circuit elements. If you want to find out the power consumed by each of the resistor, you can easily find out it by using the formula I square multiplied by R, or V square divided by R, I square multiplied by R, and V square divided by R. These are basically the two formulas for any passive element, while for any active element or a source, the formula is given like this one. So thank you very much. We will go towards more complex circuits in our next video. Till then, thank you so much. Goodbye.
Okay, welcome back, students. This is assessment problem 2.6. So we can see here that here we have another circuit, which is just like the previous circuit. Again, we have three resistors connected here. The one is in the series, the two resistors are basically connected in parallel. So there are basically many scenarios that students cannot understand what is the difference between the series circuits and parallel circuit, and there is a confusion between the students. So before going into the solution of this problem, I want to show you a scenario where resistors cannot be in parallel. So here we can see that we have some resistors. This is R1, this is R2, this is R3. So to ask the students which one of these are in series, which one of these are in parallel, the students usually are confused between finding the correct combination of the resistor. So when we usually ask the students the relationship between R1 and R3, so they say that R1 and R3 are in parallel, which is incorrect. R3 and R1 are not in parallel. Similarly, they say that R2 and R3 are in parallel, which is again incorrect. So, what is the correct answer? To find the answer of this question, there is a solution, there is a concept which you guys have to understand, and that solution is that two resistors can be in parallel if their AND to AND points are connected with each other. So these are basically now in parallel. If this is R4, this is R5. So now R5 and R4 are in parallel because this is the one end, this is the second end. Similarly, for R5, this is one end, this is the other one. These two are shorted, and similarly, these two are shorted. So these two are basically in parallel. Similarly, when we come here, we can see that, let me remove these dots. When we come here, we can see that the combination of R1 and R2. So in this combination, for the flow of current, you can see that these are connected. One end of the resistor R1 is connected to the first end of the R2. I mean, the second end of R1 is connected to the first end of R1 and so on. So, and the flow of current is same. I mean the same current is flowing through R1 and R2. So we can see that R1 plus R2 is the correct combination, and this is because the two resistors are connected in series. Okay, so these two resistors are connected in series, and their equivalent resistance can be drawn like this one. If it is R0, so this would be R0, and with R0 we have a resistor which is R3, and we can now see that the 1 and 2 first and second end of R0, which is the equivalent of these series resistors, is basically connected with the same point. So now the combination of R0 and R3 are in parallel, and we can write it like this. Okay, so this is the total R equivalent. So there is a confusion there. Mostly the students are confused in finding the proper combination of the resistors. So let me put it again. For a series circuit, if we have two resistors, this is R1 and this is the one end and the second end of R1, and this is R2, let's say resistor number 2, this is the first end, this is the second end, and if we connect them like the second terminal of R1 is connected with the first terminal of R2, and we then when we connect them, okay, let me change the color to the blue. Okay. So when we connect them now, when we connect them to a voltage source or a power source, okay, this is a DC source, V of S, this is R1, this is R2. When we connect them, so there will be the same current flowing through R1 and R2, so it means both the resistors are in series. Similarly, when we have another combination, okay, so when we have another combination, same resistors R1 with in and 1 and 2, and another resistor with the and 1 and 2. And when we connect them, let me use the same colors which I have used previously. So when I short 1 with 1, connect 1 with 1, and connect 2 with 2, and then I connect a voltage. Sorry, let me use the same color, so not to make any confusion. What was that color? That blue. Okay, yes, that's right. So when we connect a voltage source here, this is the voltage source, it is connected here. So this is voltage source, and when connecting them, we will get a total current here, which will go here, and now R1 and this R2 are in parallel. This is the symbol of a parallel, while R1 plus R2 are in series here. So this was the concept which I have gone through in this video. So hope to see you soon.
Hello students, welcome back. So previously we discussed the combinations of the passive elements, which are resistors. So in this lecture I will try to calculate the desired values which are mentioned here. So this is assessment problem 2.6, and it says that use Ohm's law and Kirchhoff's law to find the value of R and the circuit shown. So this is the value, this is the original value which I have to find out here in this question. So what basically is given, the source voltage is given, the value of the other two resistors are given here, and we have to find out the value of the other resistor. As referenced with the previous lecture, we can see here that these two resistors, the 2 points of these two resistors, if this is point 1, this is point 2. Similarly, if this is point 1 and this is point 2, so this 1 is connected with 1, 2 is connected with 2. So these two resistors are basically in parallel. So when these are in parallel, so in parallel the voltage remains same, while in series, let me write it here, in parallel combinations voltage is same, voltage remains same, while in series, when two or more than two resistors are connected in series, so the current remains the same, okay, which flows in this resistor. So let me change the color again to black because we are going to solve the question. So here in this first loop, this is, let's say, loop number 1, this is loop number 2. We have two loops, we have two loops. So first, considering loop number 1, okay, so considering loop number 1, so applying KVL here, we can see here that this is minus, this is plus, this is the passive element, so here it will be positive, this will be negative, this is again positive and negative. And in this loop, when we apply KVL, we can see that if I said this one V of S equal to 200, this is, let's say, V24, okay, so, and this is V of R. So here we can see that according to KVL, Vs is equal to, which is the voltage rise, is equal to VR plus V24, okay. This is the equation here. We know that, we know the value of Vs, we know the value of V24. So rearranging the equation, we can get VR is equal to Vs minus V24, or putting the values here, we can get 200, which is 200 volts, minus 120 volts, which ultimately will give us 80 volts for the value of V of R, okay. So we know the value of VR here. So this is the resistor, let's say this is the resistor, and the value of it is unknown. Initially the value of voltage was also, sorry, this is not a symbol of voltage. Initially the value of the voltage, which is plus minus, because the voltage drop VR was also unknown. Similarly, the current which was flowing here, IR, it is again unknown. So there are basically three, with every passive element there are basically associated three quantities, which are its impedance or resistance, the current flowing through it, and the voltage across it. I have told you that if any two of these quantities are known, we can easily find out the third one. So now we know the value of VR, but the other two are unknown. One we have to find, which is the resistance, while the IR is unknown. So I know that the value of V is equal to IR into R, or R is equal to IR into R. So to find out the value of this IR here, which is flowing here, we know that IR is equal to 1 is flowing here. So let me clean it so that you can understand and look at this thing very clearly. And let me change the color. So if this is IR, this IR is coming here, and it has been split into two currents. One is I24, the other one is I8. So according to the KCL, IR is equal to I24 plus I8. The current which is going towards the node is equal to the sum of all the currents which are going away from the node. So IR is unknown. What is the value of I24? Okay, let me give it a name. This is equation number 1. To find out the value of I24, we should have known V24 divided by R24. Do we have it? Yes, we have it. This is 20 volts, this is 24 ohm. So I24 is equal to 120 volts, and the value of resistance is 24. So this will give me 5 amperes answer. This is the answer of this quantity. Let me say it is equation number 2. Similarly, to find out the value of I8, we know that the value of I8 is equal to V8 divided by R8. Do we know their values? We know the value of R8, which is here, but do we know the value of the voltage across it? Yes, we have it, because the two resistors are now in parallel. So when two resistors are in parallel, the voltage across them remains same, which I have written here. So writing the values here, again the value is 120, this is 8, so it will be 4 to 8 4 3, so this will be the 15 amps. I8 is 15 amps. So the values are known. So let me put the values here in equation 1. Let me call it equation number 3. Putting 2 and 3 in 1, 2 and 3 in 1, what we will get? We will get IR equal to 5 plus 15. So it will give me 20 amps. So this is let me call it equation number 4. So all the things are known here, and we have this formula to find out the R. And let me change the color again, and okay, okay, this is now here. Okay, so now the two equations are here. So VR is equal to IR into R. We know the value of VR, we know the value of IR, and what we have to find out, we have to find the value of R. So putting the values here, all the values here, we will get the value of R was 80, the value of IR was 20, and it will ultimately give me 4 ohm. So this is the answer which we were looking for, and this is what we have found out. So thank you so much, and I will see you in the next video.